In this video walkthrough lesson, we're going to continue our study of division, and more specifically, we'll be looking at the partial quotient method and using it to solve word problems with double-digit divisors. And this is Standard 5 NBT B6. We'll be looking at this worksheet. You can go to worksheetsandwalkthroughs.com to print out a copy for yourself. You'll find it under our division video walkthrough section, and it's entitled The Partial Quotient Method, Word Problems with Double-Digit Divisors. Here are the directions. Solve the following using the partial quotient method. Multiply to check your work. We have 2 problems, and let's take a look at the first. Luke's favorite video game has 456 coins to collect. They are spread evenly throughout 24 levels. How many coins can be found on each level? So right off the bat, you probably can tell that this is a division problem. It's a classic division problem. We start out with a large amount spread out among 24 levels. Spread evenly, that is. And we can take a look at the question to find our math job. And we have that right here. Here's the question. Again, it's how many coins can be found on each level. Okay, so we're looking at how many coins on each level. We'll look for some clues in the previous sentences. Luke's favorite video game has 456 coins. That's a pretty important bit of information. You're probably thinking that. Good for you. So he's got 456 coins to collect in the entire game, and they're spread evenly. So evenly. We talked about equal groups when we divide, so there we go. Evenly throughout 24 levels. How many coins can be found on each level? Okay, so now you're probably thinking, oh, we should set that up as a division problem. Well, right again. So we have 456 coins in the entire game, and there are 24 levels that they are spread evenly through. So with the partial quotient method, you really should take this line above the dividend. Your quotient will eventually sit on top of that line, but you'll take this line and you'll extend it downward. And now it's very similar to our area model that we use to solve other word problems. You can go to worksheetsandwalkthroughs.com to check out those lessons and worksheets. But this one in particular deals with the partial quotient method. So you're really breaking it up into more manageable pieces. So you're thinking to yourself, 24 goes into 456 how many times? Or 456 divided by 24 equals, what would that be? That's what we're trying to find out. So let's give it a shot. We've got 24 can go into 456. Well, again, like in the area model, we want to use benchmark numbers. So in this case, we are going to use a benchmark number of 10. So you can think to yourself, 24 times 10 equals, well, let's see what that would be. Well, 24 times 10. And if you're not sure, you can show your work on the side. It's always a good idea to prove you know what you're doing. So we've got 24 times 1 would be the basic fact. So anything times 1 would be the identity property. Anything times 1 would be the number itself. So in this case, it's 24. And since we're dealing with that 1 in the tens place, we really need to tack on another 0 because it's like 24 tens or 240. So now we're thinking 10 times 24 or 24 times 10 equals 240. So far, we've got 24 times 10 equals 240, and now we really eventually want to break down this 456 as close to 0 as we can. So here we go. We'll subtract. 6 take away 0 equals 6. 5 take away take away 4 equals 1, and 4 take away 2, or 4 minus 2, equals 2, giving you 216. If I'm going too fast for you, feel free to pause the video and resume whenever you're ready. All right, so now we're thinking to ourselves, okay, 24, our divisor, how many times does that go into 216? Well, we know that 24 times 10 is 240, so times 10 would be too much. We could break that down into something a little more manageable. We could think of it as, well, we could try 24 times 5. Now again, you probably don't know that off the top of your head, so it's good to multiply on the side to show your work, kind of prove you know what you're doing. Set up the lattice methods. We've got 24 times 5. Let's try that. All right, if you need more info on the lattice method, please feel free to check out our video on that. Here we go. 5 times 4 equals 20. You're probably thinking that. Good for you. And 5 times 2 would equal 10. Now we add diagonally with the lattice method. 0 plus nothing would be 0. 2 plus 0 would be 2. And 1 plus nothing would be 1, giving us 120. Okay, so that would work. We could use that. So we've got 5 this time. 5 times 24, or 24 times 5, would equal 120. And just like in the previous step, we are breaking this number down, and we'll have to subtract to see how much we have left. 6 take away 0 equals 6. 1 minus 2, well, you can't do it, so you do need to borrow, so that will become 1. And we're borrowing that from the next door. It makes 11, so 11 take away 2 equals 9. 1 take away 1 would be 0. So now we have to think to ourselves, 24 goes into 96 how many times? Well, we know that 24 times 5 would equal 120. So what if we break it down into another easier number to work with? Well, how about 2? We'll try 2. So here we go. We've got 24 times 2. We'll do the traditional multiplication method here. 2 times 4 would be 8. 2 times 2 would be 4. Ah, I see. So now that would work, so we can put our 2 over here, because 24 times 2 equals 48. We'll subtract. 6 minus 8, can't do it. You need to borrow from the 9 next door. That becomes 8, becomes 16. 16 minus 8 equals 8. 8 minus 4 equals 4. Well, look at that. We have 48 remaining. Well, we've already seen that 24 times 2 equals 48, so we've already done the work for ourselves. So we can continue with that. We'll put 24. 24 times 2 would equal 48 once more. 48 minus 48 would indeed be 0. So now we have broken 456 down, and we're left with 0 left over, or no remainder in this case. So now all we have to do is add up what we have in this column, or in these columns. So really, you're kind of breaking it down. You're saying, okay, 24 times 10 plus 24 times 5 plus 24 times 2 plus 24 times 2. So how many times did 24 go into 456? Well, that would be, we'll add these up. It would be 10 plus 5 plus 2 plus 2, or you could add the ones first. 0 plus 5. 5 plus 2 equals 7. 7 plus 2 equals 9. And we have 1 here in the tens place, so that would be 19. So if we've done this correctly, it's always good to check your division with multiplication, but let's check this out. So now we're saying that 24 went into 456 19 times. And to check our work, you want to use the inverse operation, okay, of division. So the opposite or inverse operation is multiplication in this case, because we're dividing, and the opposite would be to multiply. So now what you want to do to check your work is multiply this divisor by the quotient. Let's do that right now. All right, I'll use the 24 times 19. Why don't we show our work with the lattice method again? 24 times 19. You can see it's a 2 by 2 multiplication problem, so we're going to set up a 2 by 2 grid. It looks like a window pane there, so remember to set it up with the lattice. You go corner to corner and through, corner to corner, corner to corner and through, corner to corner and through. Okay, so now we can multiply. We've got 1 times 4 equals 4. Little identity property going on there. 1 times 2 equals 2. Again with the identity property. Now we do 9 times 4 equals 36. You're probably thinking that good for you. 9 times 2 would be 18. Now we add these up diagonally. 6. 4 plus 3 is 7. 7 plus 8 is 15. Bring that one up. So we have 2 plus 1 equals 3 plus 1 more would be 4. And we're back to 456. And look at that. It checks right out there. So you can see that we had 456 and it's equal. Okay, so that checks out. We multiplied our divisor by our quotient and ended up with our 456 again. So now we can answer our question. And think about, does this make sense? How many coins can be found on each level? If you look at that, there's our quotient. 19 coins could be found on each level. So we can put that in a sentence and say 19, whoops, let's change that. 19 coins can be found in each level. And there you go. There's the solution to the first problem. Now we'll move on to the second example. Allie loves grape juice. She bought 357 bottles of the delicious beverage. If she drinks 21 bottles per week, how many weeks will it take Allie to drink it all? So now we've got our math job in the question there. Probably getting used to thinking that. Good for you. All right, so if she drinks 21 bottles per week, how many, there it is, how many weeks will it take Allie to drink it all? We've got some important clues listed before that, now that we know what our math job is. She loves grape juice. Story information, she bought 357 bottles of the delicious beverage. If she drinks 21 per week, 21 bottles per, or meaning each or every week, how many weeks will it take Allie to drink it all? So again, we can set up our division problem. It looks at first like it's the traditional method of dividing. So we've got the 357 bottles that she purchased all together, and she drinks 21 per week. How many weeks will it take Allie to drink it all? So let's find out. We've got the partial quotient method going on here. We'll run through this a little bit quicker this time. And again, if you need to pause the video, feel free, or if you want to just pause the video, try it by yourself and check the answer, that'd be great too. So now we've got 21 goes into 357. How many times? Again, I like using that benchmark number. Let's change our marker though. I like using that benchmark number, 10. It's really easy to work with. So 21 times 10, 21 times 10 equals, well, we've got 21 times 1 You probably know that it's 21. Good for you. And since we're multiplying by 110, it would be 210 in this case. So we'll tack on that extra 0 there. You saw that. Okay. So now we'll put that under here and subtract it from 357. All right, so now we've got 7 minus 0 would be 7. 5 minus 1 would be 4. 3 minus 2 equals 1. So 21 times 10, well, that would be too much to fit into 147 now, because we're thinking 21 can fit into 147. How many times? Well, we can try that 5. So we've got 21 times 5. 5 times 1 is 5. 5 times 2 is 10. 105, that would work. So let's use 5. 105. Seven minus 5 would be 2. 4 minus 0 would be 4. And 1 minus 1 would be 0. So now we're left with 42. And so far we've got these partial quotients over here. We use a 10 and then a 5. Now we're left with 21 goes into 42 how many times? Well, you're probably thinking, if I doubled that 21, I'm thinking it would be exactly what we need. If you're thinking that, good for you. So yes, we'd multiply that by 2. So 21, our divisor, times 2. And what would that be? If you're not sure, again, show your work. Always good to do that. 21 times 2. Remember, we're multiplying it by 2. 2 times 1 is 2. 2 times 2 is 4. And look at that. You've got 42 over here. That's exactly what you need. 42. Subtract that. And, of course, 42 minus 42 would be 0. Now we've got to add up these partial quotients. 0 plus 5 is 5 plus 2 equals 7. And we'll bring down that 1 in the tens place to be 17. Now again, we'll check our work. We've got 21 times 17. We're hoping that it equals 357. 21 times 17. All right, why don't we use, to check our work, the distributive grid method. 21 times 17. If you're not sure how to use the distributive grid, feel free to check out our videos on distributive grid, and you can follow along with those worksheets as well. So it's similar to the lattice method. However, you break down the numbers by their place value. So in this case, we had 21, so it's 2 tens or 20, and a 1 in the ones place. 17 has 1 10 or 10, and 7 ones. So now we can multiply. 10 times 1, well, that would equal 10. 10 times 20, well, we've got our basic fact of 2 times 1 would be 2. And we have dealing with tens here, so we can tack on these 2 zeros. And that would equal 200. If you're thinking that, good for you. 7 times 1 would equal 7. And 7 times 20, or 20 times 7, well, I'm thinking basic fact of 20 times 7. 2 times 7 equals 14. And we're dealing with 2 in the tens place, so we have to tack on that extra 0 there, giving us 140. So again, we're multiplying 21 times 17. And we've broken it down, distributed out our values for each of those places. And now we have to add them all up. 200 plus 140 plus 10 plus 7. Okay, so we've got 0 plus 7 is 7, 4 plus 1 is 5, and 2 plus 1 is 3. So we're giving us 357. Let's make sure that checks out. That should be our dividend. Let's see, 357 here. Yes, indeed, we have it. That does check out. Again, 357 down here, and we checked out at 357. So in fact, 357 divided by 21 equals 17. Now we have to apply that to the problem, make sure we answered it and solved our math job. or did our math job, I should say. So if she drinks 21 bottles per week, how many weeks will it take Allie to drink it all? It should take 17 weeks, and we've checked it out. And we can write that in a complete sentence now. So it will take Allie 17 weeks to drink it all. So put that in a sentence. It will take Allie 17 weeks to finish the grape juice. Or drink all the grape juice, that's fine too. To finish the grape juice. And there you have it. This is a quick look at the partial quotient method for solving word problems with two-digit divisors. Thanks for checking out worksheets and walkthroughs.com, and we'll see you again next time.